So, standard 2.1 is state the locations and describe the functions of each layer of the skin. The first question is, what are the three layers of the skin? The three layers are going to be the epidermis at the top, the dermis underneath that, and the hypodermis. And we'll go into what each one is made of. But the three layers are the epidermis, small, the dermis, and the hypodermis. What are the 5 layers of the epidermis? So in this picture, we are looking at the very bottom of the epidermis. Is going to be the basement membrane, which is right here. So in this picture, that is this line right here, the basement membrane. We're starting there. The bottom layer is going to be stratum basal. Then it's going to go stratum spinosum above that. Then stratum granulosum. Then stratum lucidum. And stratum corneum on top. What does each layer do? Well, we could talk about the keratinization process that happens. What happens in the epidermis is cells start at the very bottom as the live cells, and they divide by mitosis, and some of the cells move up to the next layer, stratum spinosum. So we could say stem cells make more cells, some get pushed to stratum spinosum. In stratum spinosum, cells are going to become keratinocytes. Keratinization. Keratinocytes. Those sound the same for a reason. They're going to divide and make more cells and get packed together. And they're going to start making keratin and keratohyalin. Keratin and keratohyalin. Keratin and keratohyalin are... Keratin is a tough protein that makes the cells strong. And keratohyalin dehydrates the cells. In stratum granulosum, this happens. The keratin starts stretching the cells out. It's super strong, and it makes them long and thin and strong. See how they change shape from this nice round thing to this long and thin cell? That's because keratin stretches them out. And keratohyalin is going to dehydrate them. So keratohyalin granules in here are going to dehydrate the cells and shrink them and shrivel them up. They're going to take water out of the cells and make them smaller. That's in stratum granulosum. Keratohyalin in a hard protein envelope form. The hard protein envelope is that keratin protection. And the key thing you need to know is cells die. Cells die in stratum granulosum. This is where cells stop being alive. The layer above that is stratum lucidum. It's an extra layer in thick skin. So just for added protection, we'll have stratum lucidum sometimes, where like in the palms of your hands and your heels. Same thing as stratum granulosum pretty much, just more of them, another layer. The last layer, the outermost layer, is stratum corneum. That is where cells have, dead cells, right, have a really strong protein coat, and they contain keratin. That's what makes them that strong. And we don't need to worry about the lipids of fats. We did talk about that. But cells have been fully keratinized, meaning they've died. Nice, let me spell that right. Keratinized. They're made mostly of hard, strong, protective keratin. That is keratinization. What does the epidermis do for the body? The functions of the epidermis are be a barrier to injury, protect against contamination, and protect against moisture loss. Injury means that imagine if we get scratched, your organs get scratched with a nail, your organs are going to bleed because they're not very strong, or they don't have that protection. Our skin is way different. We can scratch our skin all day and we won't bleed until, after we've been scratching it for a long time, because it has been keratinized. And so it is a lot better at protecting us from scrapes and cuts. It protects us from injury. It protects us from contamination, which is protection from bacteria and viruses getting inside of us, because the outer layer of the skin is dead. So bacteria and viruses, contaminants, don't have anywhere to live. Because the outer layer of the skin doesn't have the water and nutrients, bacteria and viruses need to survive. The outer layer of the skin is dead, so they don't need water and as much water and nutrients because they're already dead. That means bacteria and viruses can't survive. Bacteria and viruses won't grow. And this barrier, these cells stuck together, will protect against bacteria and viruses getting inside of my body because this is a wall. The moisture loss. The epidermis keeps water inside of us and outside of us. These cells stuck together, stratum corneum up top right, are strong, make a wall that water can't get in. It's really hard for water to get in, and it's really hard for water to sneak out. That's important because we already lose water all day long because it evaporates from our skin. The epidermis helps keep that inside of us because it doesn't need water and it makes that wall. Without the epidermis, you would have to drink gallons and gallons and gallons of water a day because you would lose so much. So it's a good thing we have that, so you don't have to live next to a lake. If we go swimming, we don't blow up like a balloon because the epidermis blocks water from coming in. Without that, water is just going to come inside of us and make our cells get huge, and then they're going to explode and we'll die. So we need this epidermis so that we can block water from coming inside of us. So it protects against moisture loss and keeps water outside of us too. What are the two layers of the dermis? The two layers of the dermis are the papillary layer up top and the reticular layer. If you look at this picture, you can see the difference. Papillary, just plain pink, right? Some blood vessels here and cells, and a few of these lines, which are fibers. It is some cells, some fibers, and blood vessels. The reticular layer has tons and tons and tons and tons and tons and tons of these scratches because it has tons of fibers, collagen elastic fibers. It does not have cells, and it doesn't have as much blood. It is full of these fibers. That is the reticular layer. What are each of the two layers made of? We just said that. The papillary layer is made of cells and some fibers and more blood vessels, right? The reticular layer is made of collagen and elastic fibers to make the skin strong and stretchy. What does the dermis do for the body? Well, we need to have these blood vessels here in the papillary layer because the epidermis has no blood. Look at that. There are no blood vessels in the epidermis. So I need to pass nutrients to the epidermis. So I'm going to have these blood vessels that are going to be right up next to it so I can pass a lot of stuff across as fast as possible. So I need to give nutrients from blood to the epidermis. And also, the dermis, the reticular layer specifically, is going to make the skin strong and stretchy. I want my skin to be strong because I want to be able to grab it and pull and not have it rip. I need my skin to be a good protection, so I need to be able to grab it and pull it in every which way and not have it rip on me. So we need our skin to be strong, and it does that because of the collagen in here. And we want our skin to be stretchy because we want our skin to be able to move with our body, right? And we want it to be able to stretch and snap back into place. You could do this on the back of your hand. You can stretch the skin and let go, and it'll snap back. If you don't have that stretchiness, your skin is going to get stretched and stay up there, which is wrinkles. We want our skin to be stretchy and strong, and that's what the reticular layer will do because it has collagen and it has elastic fibers. And last but not least, it also is going to have the other structures we have in the skin. You can already see some nerve fibers here, and we're going to have hairs that are in our skin. That come down into here. We have sweat glands, sebaceous glands. Those are all going to be in the dermis. Basically just because it's the biggest, but we need a spot to put things. That's where they will go. What is the hypodermis made of? The hypodermis is made of these yellow and cells, right? Adipose tissue and arteries, the red, and veins. Adipose tissue, the yellow cells, is going to be lots of adipocytes, which are fat cells. And the arteries and veins is blood vessels, right? They carry blood. What is the hypodermis made of? Adipose tissue, adipocytes, and arteries and veins. Why do I have that? I need arteries and veins because I want to transport the energy from fat to the body, right? I have fat in these fat cells. I'm going to pass it to the blood so it can shoot off to the rest of the body. And I need to get energy to my fat cells. Without this, I would give off my energy and it would take a million years to get to the rest of my body. So I need the blood vessels to make that process go really quick. What does the hypodermis do for the body? The hypodermis is going to insulate, store energy, and cushion the body. It is going to do insulation because just like whales in the sea have blubber to keep them warm, we have fat to keep us warm. Our fat is going to keep the heat inside of us, from getting out. This fat is going to do that insulation. Fat's going to also store energy just because it's fat, right? Fat is energy storage. I take energy, I stick it in here. After I've eaten a meal, and then later during the day when I'm not eating, I take it back out and give it back to my body. That way I don't have to eat all day long. I can eat in meals. Fat is also going to cushion our body. Fat is soft and squishy, so when our organs are hit smack into fat, fat is going to squish and make it so that fat is going to squish and make it so that our organs don't get hurt. If our organs bounce on fat, they're going to be safe. Imagine if your organs hit bone. You jump around and your lungs smack into your ribs. It would be really painful and you'd probably start to bleed, which would be really bad. You want fat so that your organs have cushioning and can move around in your body and not get hurt. So fat, the hypodermis, gives us insulation, cushioning, and it stores energy. The end.